all, welcome to our channel. So in this video we will talk about the grounding of USB protection devices. So over USB there is over USB interface that is designed for your circuit and in your system. There is definitely protection involved, right? The TVS diodes that are used uh, on the data lines protect your circuit from the ESD in any other transients, right? So you use those diodes uh, in your circuits because USB is always a interface which you plug in with your hand. So there is some kind of manual activity involved, and if there is any static energy that flows because of your manual intervention or manual activity, then that could cause a damage to your port. And at some moment, you see that your circuit is not functioning, but everything looks fine, nothing burnt, but it just stops working. So that is one thing. And second thing, the EMI/MC aspect of it. So we'll just go to the circuit. So it is a simple USB interface circuit which is used widely in our embedded boards. So the J1 you see here is a USB Type A connector which has 4 pins: VCC, data lines, and then the ground, and then the shield lines. So the shield lines are the external enclosure pins that extend onto the board. So when you place your USB connector on the board, those two lines you can see here. So these are the pins. The on the right and left of the USB 2.0, you see 2 pins, right? Those are the shield pins which connects to this external body of the USB connector. So that is actually called a shield ground, which is different from the circuit ground. So circuit ground is the ground that is used on the PCB, which is represented by GND. And then we'll talk about those grounds. And then we have the diodes. So the symbol basically is represented as normal, but there is a TVS diode that is used on the data lines. And then there are termination resistors. So now, one of the common mistake that designers do is connecting the diode grounds to a circuit ground. So now, in that case, what happens is if there are any external energies that flow into the circuit, they just tend to flow to the entire ground rather than going out of the ground. So that means you're not giving a shortest path for these transients to pass out of the board, but you are giving a path to the board. So the major point here is whenever you are grounding these diodes, these protection diodes, it is important that you connect them to shield ground. Now there are two scenarios. Your circuit might have an enclosure, or you might be designing a simple standalone board, like a board which is commercially available and you can buy in the market. So there could be two types. In that kind of boards, you might not have an enclosure, but still you design a PCB with mounting holes on it. So you can see in this is the in a, kind of board we are talking, or it could be a controller that reads the USB lines and then processes. So that the board could be an extension or a standalone or a complete system with an enclosure. So two scenarios would be there. If you have an enclosure and then the entire system, in that scenario what happens is definitely the grounding of this connector would be done to the shield ground, and then the diode path connects to the should connect to the shield ground directly. If you are having a standalone board, there is no way that you can have a separate shield ground, because you do not have um, a enclosure ground, but the only connection that you would have is an external cable. So in that cases also, it is good to have the shield ground separate, such that the entire energies escape out of the board easily. So the designers use these in a mixed manner. So they will connect this to a shield ground, but they'll connect these two diodes to a circuit ground, which could be drastic, which could give drastic scenarios, like unnecessarily the board gets affected by these transients that pass onto the board, which should not happen. So now coming to the grounds, so these two, ground and shield ground, shall be tied somewhere in the circuit. So at the end of the day, the design should have a common ground. So the ground and shield shall be made common. So the common practice in USB is the ground and the shield ground are made common through a RC, R and C in parallel, and then they are made ground. So this way, those two grounds shall be made common. So this simple this simple connectivity should not be missed in our designs. So in your designs, ensure that the protection diodes are all connected, and then these should be placed in your layout. These diodes should be placed as close as possible, very less inductance, and then the shield should be connected directly with a very little track. So that meant in most of the designs, you won't have enough space to place these diodes on the top, so you'll have them on the bottom and directly connected. So if we see this connection, so these are the bottom, right, and these are connected. So now they'll be placed somewhere around this area underneath the USB 2.0 based on the size restrictions, and they'll be used. So that is how they are used. And anyway, the selection of the diode is not in the scope of this, because USB is considered as a high speed design. And for this design, selecting a diode has specific rules. Like example, you cannot select a diode with very high capacitance. So the capacitance should be as low as possible in the around the value of picofarad. So ensure that your grounding is done in this way, and your diodes are selected such that you will have a first pass scenario with respect to these USB grounds. So thanks for watching. Please post your comments. This is a live topic, and there could be many questions that could come up. Please post your comments. Let us learn together. Please like our video, subscribe to our channel. Thank you.